Going to now discuss the different types of batteries that we use using the same concept of redox reaction to generate the electricity. So most of the commercial batteries that you have are what we call dry cells. So in this case, that electrolyte that we use where the ions allow the electrons to flow is made into a paste. And that makes it really easy to transfer around because you don't have liquids that are sloshing around. So the batteries that have liquids are called wet cells, and the only one that's in wide use is the lead acid battery that are in your car. So that actually have acidic solutions in it, and it looks like this, right? So it has a container where there's these plates that are submerged in the acid solution, and the plates make up the anode and the cathode. One plate is made up of lead and the other one is made up of lead oxide. Lead oxide is the anode, the lead is the cathode, the solution is sulfuric acid. All the other batteries that we know of are dry cells, and we have a number of them that you're probably familiar with. Those alkaline cell batteries in AA, AAA, and even the larger batteries like the C and the D batteries. They all look like this. They have an anode and cathode, and everything is packed up within it. If you look at that battery carefully, you see that there's a plus N and a negative N at the bottom. That's because there's the two electrodes that make up that battery. One is usually some type of a zinc, and the other one is carbon that serves as the positive electrode. You might also see mercury batteries that people put in watches. These look really flat like a coin, but it's actually still a cylinder, right? And so you packed up the metals into really thin cylindrical shape. Your phone and your tablet and so on, they usually use this lithium ion batteries. All of these batteries have their own mechanisms to generate electricity, and the explanation of this is well beyond this class, so we're not going to get into it, but it's just something to understand that there's these different types of batteries. All of them use the same exact principle of a redox reaction shown here to generate electricity. Now, the other type of applications that we use that require understanding of redox reactions is electric and fuel cell vehicles. Electric vehicles, they use electric motors, but the motors are being powered by rechargeable batteries. So again, the batteries is the primary source of energy that provide that electric vehicle a way to move, and that replaces your internal combustion engines. Now, of course, this is beneficial because it reduces greenhouse gas emission. The standard combustion engine produces a lot of air pollution, as we discussed before, like all those nitrogen oxides and carbon dioxide and so on. The electric vehicles do not produce that. You can take a look at some comparisons here with respect to the internal combustion engine and the electric vehicle. Now, the interesting thing is, you might not produce a lot of CO2 in the actual use of it, but in the production, you might use a lot of processes that produce CO2. So when you take a look at electric car, and if you're kind of concerned about the environment, you want to look at CO2 emission, you want to look at the whole process from production all the way to the end of the car life. And in some cases, in the life cycle, they actually do produce a substantial amount of CO2 just because there's a number of other things that they're using that that produce CO2 in that application. So that's something to keep in mind when you're thinking about these electric vehicle applications. Right now, it's not really that widely used because there's charging that needs to happen, right? So we have a lot of gas stations in the United States, but we don't have a lot of charging stations for the electric vehicles. So those have to be built up in order for you to be able to fill up your electricity, recharge your battery, just like you would go into a gas station. Now, fuel cells is another application that doesn't use internal combustion. It goes through the same type of redox reaction principle. However, in this case, it's involving hydrogen and oxygen. So what happens is you react hydrogen on one side and oxygen on the other side, forming your anode and your cathode, and that reaction produces just water. So literally there's no carbon dioxide that's being generated at all in that reaction. And The most common one is this type of fuel cell with hydrogen and oxygen. It's the flow of, in this case, hydrogen ion from one side to the other that generates the electrical current to power the electric motor. You can use this for longer driving range, but the problem is carrying the hydrogen is really difficult. That's a gas, and trying to liquefy it, you're going to need a sizable container to carry that. The oxygen is available from air, so that's not a problem, but it's the trying to work out how to store and transport the hydrogen in the vehicle is what makes it harder to use as of now.